Alright folks, let's do this question. So I'm sure this part is pretty self-explanatory and straightforward, so let's just skip it and let's carry on from here. So in this case, I'm just going to draw a big ass line, and because I'm combining everything, I'm combining everything, so my denominator is essentially the same as left hand side. And then I'm just going to use different colors. So A will be, so in this case I just take the term under the B and the term under the CX plus D. So in this case I get X minus 1 and X squared plus 4 plus B, term under the A and then the term under the CX plus D. Last but not least, let's not forget our CX plus D, and the terms. So the terms is basically X plus 1. Why am I using square bracket? I have no idea. I just thought it would look better. Anyway, nothing too deep. So what you can do is you can compute this whole thing together, or what I like to do is I like to skip the step and then just compare the terms. Okay, but for the sake of this learning, I am just gonna compute everything so that it's very, very easy for everyone to see. Oh, I didn't mean to change the line color. So in this case, I'll have A over X cubed plus 4x minus x squared minus 4, okay, plus B over x cubed plus 4x plus plus x squared plus 4. And last but not least, we have if you actually simplify this, it's actually x squared minus 1. So in this case is cx over x squared minus 1. To make life easier, I'm just gonna do c over, I'm gonna square bracket so it's easier to see, x cubed minus x plus d over x squared minus 1. And then the denominator is the same, x plus 1, x minus 1, x squared plus 4. So now let's compare coefficient. Okay, so comparing, sorry if my mic is peaking, coefficients. Let's compare the let's go down the row. Okay, so let's compare when to the power of 0, to the power of 1, to the power of 2, and to the power of 3. The reason why we're doing up to the power of 3 because that is the maximum term that we are looking at. Okay, so for 0, we have, let's look at the left hand side first. We have a 1. So 1 equals to right hand side. So left hand side must be equals to right hand side. So in this case, we are looking for those terms that have no x at all, basically. So in this case, we have negative 4a plus 4b. C will always have an x, so we can't add c. And then we have a minus d. Okay, moving on to the x term, left hand side, we have 3. Alright, just to clarify a little bit, On the left hand side, we can write it as such: plus 0x squared plus 3x plus 1. Okay, so let's continue. x1 we have minus a sorry, not minus a. I'm looking at the wrong one. We have plus 4a plus 4b, and then we have a minus c. For d is the x squared term and x0 term, so I can't do anything. Okay, now let's look at x squared. We have 0 equals to minus a plus b plus d. And last but not least, x cubed, we have 0 equals to a plus b plus c. So these are 4 equations that we can play around with. So what I like to do is actually to visualize what these equations may be able to give me. Or not say visualize, compare. So in this case, the common repeating factors are a and b, like the most common one. C and d being the different. Alright, so let me try to look at the two variables that have both c. Okay, sorry. Let me look at the variables that have d only, no c. Okay, so in this case we have 1 equals to negative 4a. Maybe I should use a different color. So we have 1 equals to negative 4a plus 4b minus d. And then we have equation number 3, which is 0 equals to negative a plus b plus d. So as you can see that the d is, I'm able to cancel out. Okay, so why not let me just cancel it out. So in this case I'm gonna take 1, is it 1? Yeah, 1 minus 3. So I'm always trying to look at variables that I'm able to cancel out. Most of the time, or commonly, I like to look at variables that are standing alone. In this case, like what I mean by that is this 4a is not really standing alone. There's a 4 to it. The b as well, there's a 4 to it. However, this d is different, and I know that I can minus the d away. Alright, so in this case is 1 minus 0 equals to, sorry, I'm adding them together. Because minus minus equals positive, so I'm just yeah. In this case, I have to add them together. So life is a lot easier. So essentially, I'm just taking minus 4a plus 4b minus d. And since add, I can just copy over. So minus a plus b plus d equals to, so 1 equals to minus 5a plus 5b. Oh, that's it. Okay. And then time to look at my other two equations, which is 2 and 4. Same thing, the c, one of them is minus, one of them is plus, so I can just go ahead and get rid of the c. So in this case, I have 3 equals to 5a. Let me see, 5a plus 5b. And then from here, I can compare the two equations. Oop. No, I pressed the eraser button. I can compare these two equations. And I notice that the 5b happens to be the common term, sorry. So I'm just going to rewrite this question as 1 plus 5a equals to 5b. Sub it in, I get 3 equals to 5a plus 1 plus 5a. So rearrange 2 equals to 10a. In this case, my a equals to 2 over 10, which is equals to 1 over 5. So now that I have 1 over 5, Can I extend this? I can. So now that I have a equals to 1 over 5, I can sub it into any of these two orange underlined values. I mean equation, sorry. So I'm just going to do the 3 equals to 5a plus 5b. So in this case, it's basically 2 equals to 5b. b equals to 2 over 5. Alright? Then I can just sub these two values into my equation 3 and equation 4 to find c and d respectively. So if you were to do that, you will end up with 1 over 5 x plus 1 plus 2 over 5 x minus 1 plus negative 3 over 5 x minus what's d? 1 over 5 over 2x plus 4. Simplify this, I get 1 over 5 x plus 1 plus 2 over 5 x minus 1 minus 3, because 5 is the common denominator, so I can bring the 5 down. So in this case, it just be 3x minus 1. So this is the equation that I will be working with for my for my integration. Okay? Sorry, it's a bit slanted. So let's integrate. Let's integrate it one by one, okay? So for number 1, if I were to integrate 1 over 5 x plus 1 is basically the same as 1 over 5. I bring out the 1 over 5 because it's a constant dx. This equation look very similar, or familiar should I say. This is, I can just take it as u, then I'm differentiating 1 over u du, which is equals to ln u. Oh sorry, integrate. Then to differentiate this, to differentiate u is basically just 1. So in this case, it is 1 over 5 over 1 divided by the differentiated term of u, which is still 1, so there's no difference, times ln u plus c, which is equals to 1 over 5 ln x plus 1 plus c. Moving on to the second one, it's essentially the same thing, so I'm not gonna go through it too much. I just want to focus on the last one. Okay, so for the last one, let me just copy and paste. Alright, sorry it's a bit messy and slanted. Alright, so for the last one, it's kind of weird. I don't really see any way that I can integrate it into ln because of the top. But I also can't really see, I can't see a clear pattern. So what I'm gonna do is I'm gonna separate out this thing first. So essentially it's just 3 over 5 x squared plus 4 minus 1 over 5 x squared plus 4. To further simplify this a lot more, 3 over 5 times x over x squared plus 4 minus 1 over 5 times x squared plus 4. Now this look a lot more believable. Alright, so let's split this into 3.1 and 3.2. Let's integrate 3.1 first. So 3.1 is basically 3 over 5 of x plus 4 dx. Let u equals to x squared plus 4 du dx equals to 2x. Half du equals to x dx. So essentially this is just 3 over 5 times half. Okay, maybe I should put a half behind. So it's equals to 1 over u times half du, because my x dx becomes half du. Okay, so this becomes 3 over 5 times 1 over 2, bring out the constant, and then 3 over 10 ln u, just sub back in the u value, and there you have it. That's 3.1. Okay, and then for 3.2, what's 3.2? For 3.2, ooh, it's a little bit tricky, but I'm starting to see a pattern. Okay, x squared plus 2x. You know what? This pattern doesn't look that good. Am I right? Well, it's not ringing any bell. If I recall correctly, integration of x plus 1 equals to tangent x plus c. Sorry, tangent inverse. Oh, okay. I'm starting to see a pattern, something that I can, a similarity, yeah. So why not let me just make it to that. So times, what should I do? I should bring out the 4. I think that makes a lot of sense. So bring out the 4 essentially just means that I have to divide everything by 4. So x squared divided by 4 is just x squared divided by 4. 4 divided by 4 is just 1. I can't really see it still. Let me try to rewrite it, okay? Maybe I should write it as x over... Okay, I'm gonna do it very slowly, okay? X squared over 2x. 2 squared plus 1. Okay, I'm starting to see a pattern. When I take x over 2, I bring out the square. Doesn't this look like whatever we have over here? Very nice. So now I'm gonna let v equals to x over 2. dv dx equals to half. dv equals to dx, I bring over the 2, so it's 2 dv equals to dx. So I have no more space to write. So essentially, I'm integrating 1 over 5 times 4 over x over 2 squared plus 1 equals to, I bring out the constant, 2 over 4 u square plus 1 du, okay, equals to Time to bring out more constant. So equals to 1 over 5 times half plus 1 du equals to 1 over 10 tangent inverse u plus c tangent inverse x squared plus c. So if I were to add everything together, I know it's very messy. It is very messy. But if I were to add everything together, you will end up with 1 over 5 ln x plus 1 plus 2 over 5 ln x minus 1 minus 3 over 10 ln x squared plus 4 minus 1 over 10 tangent x squared over 2 plus c. Where do you get each one of these from? This, you are getting it from your a, which is 1 over 5 x plus 1, 2 over 5 x minus 1, and last but not least, you are getting this from your yes, you get it. Alright, I hope this helps.